Hey everybody, today we have a problem where a circle with a known center and radius intersects the square root graph, the graph of the square root function. Now, it intersects at a point where you have rational coordinates. So let's say that y is m over n, where m and n are natural numbers, and they'd have to be natural numbers since you're taking the square root and the range of the square root function is positive. Okay, but let's say if this is true, then in order for everything to hold up, that would imply that x has to equal to m squared over n squared. Okay. Otherwise, the coordinates would not be rational. Or you can call this a perfect square rational number. It's totally fine. Normally, perfect squares reserved for integers, but you could call this a perfect rational square if you feel like using the word perfect. Now, the formula for a circle, very well known, college algebra, high school algebra. Let's see, what are the letters that stuck? H and K, I think. Circle with a center HK and a radius R. Looks like this, x minus h quantity squared. This is just the distance formula rewritten. Okay, and then this would be r squared. Right here. And again, y'all, this is literally the distance formula just written with different letters, basically. Okay, and then squaring both sides. And so that's where the radius would be equal to, the radius itself would be the square root of 58. Okay, not that we have to really mess with that too much. Okay, so this is the formula for the circle, and we know it has a rational coordinate, and it has to be rational coordinates in this form, m over n, and then m squared over n squared based on the fact it intersects with the square root graph. Okay, now, one thing to notice right now is that there's two possibilities here. You can either have 3 squared plus 7 squared. That equals to 58, right? Or you can have it in the other order. You can have 7 squared plus 3 squared. Or you could have this in either order. Now, that takes some noticing, but notice that try the other small squares. 4 squared doesn't, plus something else. 4 squared is 16. What would that be? 42? 42 is not a perfect square. 5 squared is 25. And what's the change there? 23. 23's or 33? Yeah. But anyway, these are the only squares, the single digit squares that sum up to 58, 3, and 7. And again, you can check that, but that turns out to be important. So we can check, if you want to, we can check 7 first. 7 equals to x plus 39 over 25. Okay, now let's see, what does that imply? That would imply if you subtract 39 over 25 from 7, 7 is 35. So this would imply that x is equal to 136, if I did the arithmetic correctly, right? 136 over 25. But notice the numerator is not a perfect square, and it has to be, right? Remember, the numerator has to be a perfect square. So I think I did the math right. 7 times 25 is 75 minus 39 is 136, right? So we can't use this, right? We can't use this because it's not in the form m squared over n squared. So let's try to do it with 3 right here. Okay, let's try to do it with 3. So if x is equal to x plus, 39 over 25 equals to 3. Okay, let's see, what does that do for us? X is equal to 3 is 75 over 25. 75 minus 39 is 36 over 25. And you see, this is in the form we're looking for. 36 over 25 is equal to 6 squared. You know, shouldn't waste the time, I guess, but 6 squared over 5 squared, right? But notice that y is the square root of x, of course, right? Y is the square root of x. So that's going to give us that y y has to be 6 over 5. So y'all, that's our solution. X is equal to 36 over 25, and y is equal to 6 over 5. And I can write it right up here. X is equal to, or the point of intersection, comma 6 over 5. Okay, and again, I thought it was a fine problem because if you weren't given that they were rational coordinates, right here you have, this is just a circle. So how many, there's obviously there's infinite number of points on this circle. I guess they're mostly irrational, probably countably more or whatever. You know, I think if you just picked an arbitrary x and y, this would be irrational, right? If you pick an arbitrary point on the circle, x and y would be irrational numbers. But the fact that this part about one of the points has rational coordinates gives us just enough structure, plenty of structure, in fact, to get this as the unique value. So 36 over 25 comma 6 over 5 is the solution. And I guess also right here, if this number had been too big, it would have been possible. If 58 had been too big, it would have been possible to write this in more ways than just 3 squared plus 7 squared. And that was important. Otherwise, you'd have to check them all. Let's see, 1 squared leaves 57. 2 squared leaves 54. 3 squared works. 4 squared doesn't work. 5 squared doesn't work. 6 squared is 36. And what we need, 22. So again, it's the 3 squared and 7 squared is the unique way to sum two integer squares to give you the 58 and maintain the rational coordinates. Okay, that's it. Thanks for viewing.